Understanding linear and nonlinear functions. This is on page 19 in your packets. You can also find this, it starts on page 267 of your textbook. So the ratio of the changes in two quantities, such as the slope of a line, a linear equation, is the rate of change. Yes, delta y over delta x, that's your rate of change, that's your slope. So the change in the output values, the y's over the x's, so the rate of change. You can tell whether a function is linear by finding the rate of change. Copy the table into your notes. So the x values, well, these are already in your notes. The x values go up by 2 each time, and it looks like there is a constant rate of change here. The y values go up by 6, up by 6, up by 6. But just say, for instance, they didn't go up by 2 and 6. Say this last point was 7 goes to 11, it would go up by 4, and 30 would go to 42, which it would go up then by 12. So 12 over 4, the rate of change, 12 over 4 is the same delta y over delta x as 6 over 2. So my rate of change would be 3 over 1. Just say the last point was a change in y value of 12 and a change of x value of 4. That's still a slope of 1. So yes, my rate of change is still the same. So a function with a constant rate of change we know as a linear function. Here's another one. So my x values here going up by 1, then going up by 2, going up by 3, going up by 1. How are my y values changing? Oh, down by 6, down by 12, down by 18, down by 6. So my delta y over delta x, my change in my y values over the change in my x values, my slope, negative 6 over 1, which does equal negative 12 over 2, which does equal the same rate of change, negative 18 over 3, negative 6 over 1. So yes, my slope, my rate of change is my y values go down by 6, my x values go up by 1. The change between any two pairs of input and output values, input being the x and output being the y values in a table, may not always be the same even in a table that does represent a linear function. To check whether the function is linear, be sure to find and compare the rates of change for the pairs of input-output values. If they are the same ratio, negative 6 to 1, then yes, this is a linear function. And another one. So my x is going up by 1, then it's going up by 2, then it's going up by 3, then it's going up by 1. First, my y values are going up by 3, so my delta y over delta x here starts off at 3 over 1. Then 12 over 2, well, that does not equal 12 over 2. That's 6 over 1. It does not equal 33 over 3. That's 11 to 1. So they are not the same ratio. And this one's 15 to 1. So they are not equal. So there is no constant. When it does not have a constant, not a constant rate of change. This is not an equal ratio here. So a function with a varying rate of change is nonlinear. There's no constant here. So my delta y over my delta x is not the same. The table shows the cooking times recommended for roasting turkeys of different weights. Tell whether the relation between the weight of a turkey, x pounds, and the time it takes to roast the turkey, t hours, is a linear function. Well, yes, I happen to know that this is linear. Going up 5 pounds adds a half hour of time. Going up 5 pounds would add a half hour of time. going up 10 pounds would then therefore add an hour of time. This is linear. Is the function linear? Yes. Delta y over delta x, so 5/10 divided by 5 equals 1/10, or a 1:10 ratio. So yes, it is a linear function. So what would happen, which always happens to be the case, if you buy, for instance, a 21 4/10, that's the size of my turkey for this Thanksgiving, how long do you cook it? Well, you could, for every 5 pounds, or you could use the rate, which would be even better, for every 1 pound you cook it, increase in 1 pound, you would cook it 10 more minutes. So if it's 21 4/10, how many minutes? You could set up a proportion and solve this to figure out how to cook your turkey, which in proportional equal ratios, so proportional reasoning there. So yes, it shows a constant rate of change, so it is a linear function cooking your turkey. What if you have a graph? Can you identify whether the function is linear or nonlinear? Well, you already know that linear functions have a constant rate of change, slope. And the graph of a linear function is a line, which that's why it's a straight line. So it does have the constant rate of change in it, the slope. And linear equations can be written in the slope-intercept form. So there's my constant rate of change. So since a linear function, by looking at it, is it a straight line, I'm going to know that's a linear function because I can set y equals mx to b to that line. So is this graph linear? Yes. I'm going to put some arrows on this. I would say this is a linear function. Find the slope using various points. Well, down 3 and over 1 here. My delta y over delta x, my slope equals -3 over 1. And yes, it's the same rate of change here, -3 over 1. So you can see that the slope of the line is constant. So the straight line graph does represent a linear function. The graph shows the relation between the area of a square, A, square centimeters, and its side length, S, centimeters. Explain why the relation between the two variables, A and S, is a function. Well, for each side length, when you square it, you're going to get a unique output. So yes, it is a function. Each input has a unique, or exactly one, output. So it is a function. That's why it's a function. It's a one-to-one function. We could put some more points on here. When the side length is 4, the area is 16, 4 squared. When the side length is 5, the area is 25, 525, and 636. Explain whether the rate of change of this graph is constant. Well, it's not. If I use any of these 2 points, if I tried to do delta y over delta x, you'll see that it's not a constant. So the first 2 points that I have on here, 416 and 39, my delta y is 7, my delta x is 1. Well, then if I go from 525 to 416, my delta y would be 9 to 1. So that's not a constant rate of change. It's not constant. And yes, it's not constant because it's not linear. Because the graph is not a straight line, it represents a nonlinear function. In fact, this is a quadratic function. It's a graph's like a parabola. You'll see that a lot next year. Is this function linear or nonlinear? Well, it looks like a straight line to me. I would say it's linear. If it's linear, find the rate of change. Well, 2 easy to read points would be this beginning point and ending point, it goes up 5 and over 6. So my delta y over delta x here would be 5 over 6. So it does have a constant rate of change, up 5 or over 6, or it could be for every going up 1, my x would be going, my y would be going, if you do 5 divided by 6, it's going up decimal point 8/300ths repetent, so, and over 1 if I wanted to put it in smaller terms, but I would just leave it 5 over 6. Is this function linear or nonlinear? Well, it's definitely a curve, so I would say that's nonlinear. It's a curve. It's not a straight line. There is not a constant rate of change. It's a curve. It's not a constant rate of change. Easy to read points here. So it goes up 1 and over 2 there, but it's not straight, so it's not going to have a constant rate of change. And then from this point to this point, so here it's up 1 over 2, but here it's up 2 and over 1. So it's not a constant rate of change. You can see that. And that's it for today.